All right, hopefully this works. Okay, so we are going to get started with this. And what we're doing today is something called linear programming. And I tried to make the problems that we're doing in class, as well as the problems you have to do at home, to be where what's going to happen today is you're going to kind of make that triangle you did in your yesterday. Okay, so you're going to close in a triangle that is said to be bounded. Okay, and then other times you are going to have a situation where it's not bounded, but you still have what we call vertices here. So what you're looking for today is where do all your lines kind of overlap, the shading. And then when you do that, they're going to be giving you a function. And it's going to look like this, like f of x, y equals, and it might be 2x plus 3y. And they'll tell you that they either want this function to be a minimum number, a maximum number, and then when we get to the word problems, we will be finding these points. And let's see, this is 1, 2, 3, 4, 1, 2, 3, 4. This is the point 4, 4. This is negative 3 up 3, so that's negative 3, 3. So what you will do is you'll put 4, 4 in here. So you put 4 in for x, 4 in for y, 2 times 4 is 8, 3 times 4 is 12, and that equals 20, okay? Then you put negative 3 in for x and positive 3 in here. 2 times a negative 3 is negative 6, 3 times 3 is 9. When you add those together, you get 3. Sometimes you might have, like in this case, there's 3 vertices, okay? There is a problem, I believe I assigned this one, where you have kind of a rectangle looking thing on your graph when you get done. So it might look something like this. So say this is cross, and then you'd have 4 vertices, okay? When you get those vertices, then you go to that function and you put it in and you evaluate every function at those points, or you evaluate that function at the 4 points. And then they'll ask you specific questions. The first type of problem we're going to do, they're going to ask you what's the minimum value you get and what's the maximum. So like here we got 20 and we got 3, so this would be our minimum, this would be our maximum. Later on in the homework, they ask us just like, find the minimal cost for this business. Then you would just look for the smallest one, okay? They might ask you, what's the maximum profit? And then you look for the biggest one. So we're gonna do a bunch of questions today. I did put on here those shading rules. Did you guys use these shading rules, or do you still pick a point? It doesn't matter, you can do it either way. When I show you today, I'll probably use these, but if you would rather pick a point on one side, just so you know, let me just check here. Okay, shoot. All right. So you can pick a point on one side of the inequality and see if it works, and if it does, great. If it doesn't, then what you would want to do is go ahead and shade the other way. Okay, so I also put on here, again, anytime you have x equals number, you're gonna go to where x is on that graph and put a vertical line. And then whenever you have y equals some number, that's going to be a horizontal one, okay? Now, these are the rules that we're kind of going to be going through today. First thing that you want to do is you're going to write what's called constraints. They'll look like x is greater than or equal to 0. Y has to be between. If you see something like this, this means y has to be between 3 and 6. You might have y is greater than or equal to 1/2 x plus 3. Okay, those might be your 3 constraints. Then what we're going to do is, and then you always are given some type of f of x, y. This is called the function of x and y, and then it'll say something like 2x plus 3y. Okay, so that is something that we need. We call this the, I always forget the name they call these now, objective function. Okay, so that's what they call that, is the objective function. So we would go ahead and graph these on your graph, find that enclosed spot, find the vertices of that enclosed spot, and put those vertices into our function and see which ones are minimum, which ones are maximum. And all of that is called linear programming. Okay, so let's go ahead and get started. All of your problems that you have tonight, I think I gave you 6 problems, and we're going to do one of them together. This will be due Sunday night at midnight. Okay, when you go to do these, I tried to make them all so that your vertices are whole numbers, because some of the examples they're not. So I tried to pick out ones that were. All of them should be able to be graphed on normal graph paper like this, except for the one that we do together in class. That is going to be graphed on this sheet. We are going to do the one-word problem together. Okay, so let's go ahead and get started. In these first couple, they give you the constraints, which is nice. You don't have to figure those out, okay? So what we would do is go to x, and what they're telling us here is our x is between -2 and 6. When that's the case, you go to your x-axis, go to -2, and go to +6, and you're going to have a vertical line at each of these. Okay, now what this is saying is that x is between a -2 and 6. Okay, what that means is we want to shade this somewhere in between these. Now, again, I talked yesterday, sometimes it's better to just kind of write it a little bit at first. In fact, today, a lot of times, I just write it next to the line until I get everything done. Okay? The next thing we're going to graph is they want our y between 1 and 5. So you go to your y-axis at 1 and your y-axis at 5. And for y equals, remember from down here, whenever it's y, it's horizontal. Whenever they're x, they're vertical. So for these, they're going to be horizontal. And you should use a straight edge. Do you guys want to come up and grab a ruler? I should have set these out too. For these, we're actually looking for specific points that they intersect. So you want to be as exact as possible on your graph. Okay? The next thing that I need to graph is this one here. That's y is less than or equal to x plus 3. So here my m, hopefully you guys know, is what's in front of the x. That's 1/1. My y-intercept is at 3. Okay? So what that tells me is I go up to where my y-intercept is 3. My slope is 1/1. What that means is I just go up 1, right 1, up 1, right 1. And again, you have to be really accurate, especially where you're going to have the intersecting areas. And these are just going to be solid lines. Today, all of our lines are going to be solid. We shouldn't have any that are dashed today. Okay? And this is less than or equal to, do you guys know if it's less than, do we shade above it or below it? Below. So we're going to shade below here, all right? And now we're to the point where we can look at where does this all overlap, okay? We want our shading to be under the blue line, okay? So like under here. We want our shading to be to the right of this vertical line and to the left of that one. And we want our shading to be, I didn't do this, I should have talked about this when I did the horizontal lines. If our Y needs to be between 1 and 5, that means it's going to be between these two vertical or horizontal lines. So we're below this line, above this line, to the right of this, to the left of this. Do you kind of see where it's going to overlap? If I use, oh, let me see how I get to my, I'll do this. Oh. Okay, so not quite sure what marker I had there. Let's see if this works. Okay, it does. Do you guys see that where this is all going to work out? This is a vertice, this is a vertice, this is a vertice, and that's a vertice. Do you guys see that? Everybody okay with that? And it's going to be shaded inside of all of this. Okay. Now, you did that yesterday, and you found those vertices, okay? Today, like I said, I assigned ones that all of these should be whole numbers. It's a pain if they're not. So these are all going to be whole numbers. And we start from the origin, this one over 1, 2, 3, 4, 5, 6 up 1. So that's that. This one up here is 6 over and up 1, 2, 3, 4, 5, 6. Did you guys get 6, 6? Or is it 5? 6, 5, is it? It is 6, 6? It should be 6, 5, actually. 6, 5, yeah. Yeah, 6, 5, okay. Because this is at y equals 5. Then this point is over 2 up 1, 2, 3, 4, 5. So this would be the point 2, 5. And then this point here is -2 up 1. Is that what you guys got for your 4 vertices? Okay. Now, the way you do your assignment today, okay, that you guys should be okay with that, I would think. What you're going to do is make a little chart, okay, and say what your vertices are over here. That's part of your answer. So you would just write those in any order, okay? Doesn't matter what order at all that you write them in. So I'm going to just go 2, 5, -2, 1, 6, 5, and 6, 1. Okay, now our objective function is always this, the f of xy. That is what we're going to evaluate for each of our vertices. And if we look back, what they want is what do we get as our maximum and what do we get as our minimum when we put those numbers in, okay? If I went -5 and I put x in there as 2 plus 2, times my y is 5. Negative 5 times 2 is negative 10, plus 2 times 5, which is 10, is 0. Okay? Then we put negative 2 in for x, and we put a positive 1 in for y. Negative 5 times the negative 2 is a positive 10, plus 2 is going to be 12. Then if I put 6 in for x and 5 in for y, that's a negative 30 plus 10, which is negative 20. And then I'm going to put in 6, 1. And these can get put in any order. There's nothing saying which one has to go first. So negative 30 plus 2, did you get a negative 28? So are these the 4 numbers you got? Holler if you see that and make a mistake, okay? Now, minimum value. They're just asking you what's the smallest. Our smallest is negative 28, and it occurs at the point 6, 1. Our maximum value, okay, was positive 12. This is our max, this is our min. Our maximum value is at negative 2, 1, and that is 12. You get it? Everybody okay with that? All right, so let's go to our next one here. First thing we're going to do is plot this first thing where our slope is negative 3, 1. Our y-intercept is 6. So I'm going to go up to where my y-intercept is 6. And my slope is negative 3 over 1. So I'm going to go down 3 over 1. And this is where it's important that you really follow the graph down and use a straight edge. I'm terrible at using straight lines up here on this, but you guys should on yours. And you want to, and all our lines today are going to be solid. Okay. Now, this one was less than or equal to. So should I shade above the line or below the line? Below. So I'm going to just write that right here. Okay. Now I'm going to go to this thing that says negative y is less than or equal to x. I can't graph that yet because it has a minus sign in front of the y, so I need to get rid of that. How I would do that is divide each side by a negative 1. And when I do that, what do I have to remember? Switch the sign. Very good. So I'm going to get y is greater than or equal to negative x. So my slope of this line is negative 1, and I can think of that as over 1. And my y-intercept is just going to be 0 for that. Okay? So let's try to graph this one. We're going to start at 0. And if it's negative 1 over 1, you go down 1 over 1 repeatedly. And remember, you're always looking for where stuff intersect. So it's more crucial to be accurate. Well, not necessarily, I shouldn't say that. Be as accurate with a straight edge as you can so you can see where things intersect. Okay, now this one, remember we switched the sign and it's now greater than. So do you get that we'd be shading that one above? Okay. Our last thing that we have to graph is the y is less than or equal to 3. If it's y equals 3, do you guys remember with y equals, is it vertical or horizontal? Horizontal. So we go to where y is 3, okay, on our number, on our y-axis, go to where y equals 3, and you're going to have a horizontal line. And we're always looking at where are things like intersecting. It looks like there's a vertex right here. Looks like there's one right here. And see, my lines aren't the best. Is it down here? Is it 3, -3 that they intersect? Is that where you got it? 3, -3? Okay. Now let's look if the shading is right on that. Where would you think y is less than 3 would be? Would the numbers up here be greater than 3 or less than 3? These would be bigger, right? So shouldn't it be shaded below? So for this purple line, we want to be below. For the pink line, we want to be like this. For the blue line, we want to be like this. So do you see it's this little triangle in here? Okay. So it's going to be right in here. Now I'm going to look at what are my vertices, okay? So my vertex right here is -3 up 3, it looks like. My vertex right here is over 1 up 3. And my vertex here looks like it's 1, 2, 3, down 1, 2, 3. So it's 3, -3. I don't know if you can read that green at all, but hopefully you can. So I'm just going to copy those vertices down here in any order. 1, 3, and 3, -3. And my function here is the 8x plus 4. So that objective function that's like f of xy, you never graph that, okay? But f of xy is always just used to get your min and max. So now let's put this in. If I have 8 times a -3 plus 4 times a +3, that's -24 plus 12, so that's -12. If I have 8 times 1 plus 4 times 3, that's 8 plus 12, which is 20. And if I have 8 times a 3 plus 4 times a -3, that's 24 minus 12, which is 12. Okay? So now we have to decide what is our minimum value and what's our maximum. Our minimum is going to be this one. Our max is going to be this one. So my minimum is at the point -3, 3, and I got a -12. My max is at the point 1, 3, and I got 20. Is that what you guys got too? Okay. Like I said, don't holler if I make a mistake. Or don't hesitate to holler if I make a mistake. Okay, so do you think you get that? Do you think you need to see another one like that? Should we? Okay, I have one person that was hesitating a little, so we're going to just quickly do this. So we're going to go between -6 and -2, 1, 2, 3, 4, 5, 6, and -2, and it's y, so that means y is always horizontal. Okay. Now y is between -6 and -2, so that means it's going to be shaded in between these two lines somewhere. Okay. The next graph is y is less than or equal to 2x, so my slope is 2 over 1, plus 2, so my y-intercept is 2. So I'm going to go up to 2, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, which is the same as down 2, left 1. And like I said, you want to be accurate so that you can tell where those vertices are. All right. And this one is less than or equal to, okay? So less than or equal to means below, okay? And let me think. We have one more. Oh, I skipped this line, didn't I?
Ja, ich glaube ja. Ja, Mann.
Okay, hopefully. Okay, I think that's good. All right, so now what we're gonna do is go ahead and I missed this one right here where my slope is -1/1 and my y-intercept is 2. So for that, what I'm gonna do is go up to 2 and my slope is down 1, right 1. So again, try to be as accurate as you can. Okay, so we're gonna draw this. And that one is less than or equal to also. So here's the deal. We want to be less than this line, above this line, below this line, and below this line. So do you guys see that your shading is going to be in here? Okay. And your points are going to be this point, which is 2, -2. This point is over 1, 2, 3, 4, down 2, 4, -2. This point is over -1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. So that's -4, -6. And this point over here is 1, 2, 3, 4, 5, 6, 7, 8. Did you guys get 8 over? And 1, 2, 3, 4, 5, 6. Is this all right? Yeah. Okay, perfect. Now if we go down to our chart and put those in any order. Okay, and our objective function is right here, 6x plus 4y. So I just have to substitute that in. Now 2 times 6 plus 4 times a -2 is 12 plus a -8, which is 4. Oh, thank you. Yes, you're right. I had this point wrong. Thank you, whoever said that. So if it's -2 times 6, that's -12. So did you get a -20? Okay. Then we're going to go 6 times 4 plus 4 times a -2. So that's like 24 and a -8, which is a positive 16. Then it's 6 times a -4 plus 4 times a -6. Those are both -24. So when you add those, you're going to get -48. And then it's 6 times 8 plus 4 times a negative 6, that is 48 plus a negative 24, which is a positive 24. Is that what you guys got? Okay. Now, we're looking for our minimum and we're looking for our maximum. So it looks like the negative 48 is my min and the 24 is my max. So my min is at the point negative 4, negative 6, and what we got was a negative 48. My max is at the point 8, negative 6, and we got 24. Okay? Now, your homework is going to be mainly like this. We have one that's a word problem, and that one I am going to do with you at the end. So we're going to try to go through 2 word problems together, and then we're going to do a word problem together that's actually your homework. So if you guys look here, these are the steps when you get to this linear programming, and they actually use this. They don't solve them by hand, but they actually use linear programming in businesses to find like how many products of this should they be selling and how many products of this should they be selling to get their maximum profit. Or they might want to look at minimum cost. And you'll see an example like both of those. These are just like we did, except we have to come up with the variables and the constraints. And the other thing that's different is that they don't give you that function. You have to think about what that would be. So what I do is I always want to define what my X and Y is. And then I try to come up with a chart that helps me on these. And so it says a painter has exactly 32 units of yellow dye. So that's how much they have. So I put that here. And they have 12 units of green dye. So I put that there. He plans to mix as many gallons of as possible of color A and color B. So what we're going to do is let's let X be the number of units of color A. And let's let Y be the number of units of color B. Okay. Then it says each gallon of color A, so that's this right here, requires 4 units of yellow dye. So here's my units of yellow dye. So I need 4 units of yellow dye for every unit of it that I have. So I would take 4 from here and multiply it by X because that's how many units of color A I have. We could also go and do B at the same time. B requires 3 units of yellow dye. Okay, so that's green. For color A, it uses 3. So we're going to take the 3 times how many units we have, which is Y. Okay, then we're going to go on to color B. Okay, did I screw that up? Yes, I put this in the wrong spot. Sorry. We were doing yellow dye for color B, so that goes right here. Okay, so this is going to be 3Y. Sorry. Then they tell us that color A requires 8 units of green dye. Now, so A is my X. So I'd go 8 times X, that goes here. With the color blue or color B, it has 2 units of green dye. And remember, color B is Y. So it's going to be 2Y. Okay. Now, when you're doing these, they're asking us what are the maximum number of gallons he can mix. Okay. So his objective function here, the f of x, y, he just wants to maximize how many gallons he's going to have, and that's just going to be x plus y. X is how many of color A, Y is how many of color B. Okay? Now for our constraints. We cannot have a negative amount of a paint. So that tells us X has to be greater than or equal to 0. We cannot have a negative amount of Y. So Y has to be greater than or equal to 0. In fact, all of these linear programming problems, you're always going to be using just, once you get it graphed, you're going to be looking in the first quadrant because you're looking for positive numbers, okay? Then they tell us that he has exactly 32 units of yellow dye, okay? And exactly 12 units of green dye. So what that means is when we add these two together, we can't be over 32. He doesn't have any more than 32. So what we would say there is 4x plus 3y has to be less than or equal to 32 because he doesn't have more than that. Then if we looked at the green dye that's going to be used, that's 8x plus 2y is less than or equal to 12. Okay, so now we're going to go ahead and start graphing those. When you look at x equals, remember x is vertical. The line x is greater than or equal to 0 is this line, and greater than means it's here. Okay. Y equals 0 is this, and it has to be greater than that again. So it needs to be in first quadrant somewhere. Okay. Now what I need to do is I need to take this and solve it for y. So do you guys get when I bring that 4x over to the other side, it's going to be a negative 4x, and then I'd have plus 32. Does everybody get that? And then I divide by 3. All right, we'll finish after lunch, okay? Yeah?
When you're graphing, there is a straight line where if you take it.
Yes, I just struggle with that. But I do know there is one. Yes, thank you. Okay, I'm going to stop the recording, you guys, and then I'll open up another one after lunch. Okay? All right.